Hi, my name is Ishfaq Ahmed Bhatt, and today we are going to learn this exciting concept, that is variation of basicity of hydride anions of non-metals within same period. So if we talk about non-metals of a same period, suppose we are talking about second period of periodic table of elements, we have these non-metals, that is carbon, nitrogen, oxygen and fluorine. And if we try to make their hydrides, and according to the valency concept, in order to complete their octet, this hydrocarbon will be making CH4, nitrogen will be making NH3, oxygen will be making H2O, and similarly fluorine will be making HF. Okay? Now, you can see all of these are bonding with hydrogen atoms, so that is why they are called as hydrides of non-metals. These are non-metals. Now they have made these compounds with hydrogen atoms, that is why they are called as hydrides. Now if we talk about their dissociation, this HF can dissociate into H positive ion and F minus anion. Similarly H2O can dissociate into H plus and OH negative. NH3 will be dissociating into H positive plus NH2 negative anion. Similarly CH3 will be dissociating into H plus and CH3 negative anion. Now you can easily see we are getting these species, that is CH3 negative, NH2 negative, OH negative and F negative. So what are these? These are anions of hydrides. Now if we talk about their basicity, we have to apply a concept, that is, okay, now if we calculate the number of hydrogen atoms in all these four species, so we will be writing as number of hydrogen atoms. In case of CH3 we have 3 hydrogen atoms, in case of NH2 we have 2 hydrogen atoms, in case of OH 1 and here 0. Now if we talk about the volume occupied by hydrogen atoms in these anions, in case of CH3 it is 3 upon total number of, that is 4. Okay, so 3 upon 4 volume of this anion is occupied by hydrogen atoms. In case of NH2 it is 2 upon 4 and 2 upon 3, sorry, 2 upon 3, because there are total 3 atoms, and in case of this it is 1 upon 2 and in case of this it is 0. Now if we talk about the volume occupied by the electron, volume occupied by the electron, okay, so we will be seeing here that here is this single electron and total volume is 4, so 1 upon 4, in case of this 1 upon 3, in case of this 1 upon 2 and in case of this 1. Now you can easily see here that the volume occupied by the electron shows decreasing order when we move from F negative to CH3 negative. So now see what happens when the volume occupied by electron increases. It can be clearly witnessed that the electron shows more delocalization. That is, this electron won't be available at a localized place. That is, its ability to attract a proton towards itself will be quite difficult. That is why we say that increase in the volume occupied by the electron decreases its basicity. Okay, so now you can clearly say that if the electrons are quite localized, then it will be easy for them, for that electron to attract the H positive ion. So CH3, okay, so CH3, sorry. So in this case, what we will be saying that we will be concluding that CH3 negative ion is more basic than this NH2 anion, and NH2 anion is more basic than OH negative ion is more basic than F minus ion. And now we already know that HF is an acid and it breaks down into H plus F minus anion. Now if we look into this, HF is an acid and F is its conjugate base. And we already know that stronger the acid, weaker is its conjugate base. So if it is strong acid, its base will be weak. Okay, clear? So we can also, from this point of view, we can also conclude that F minus is a weaker base, OH minus is completely stronger than F minus, and similarly with these two anions. So with this, I hope you have understood the concept. With this, we are ending this, we are wrapping this session. Thank you.